quick agenda. I'm going to hand it over to Chris and Tim for an update on the license, and then we're going to take questions on that part of today's meeting. And then I'm going to hand it over to Brian, who's going to talk to us about his awesome project called Kelvin. And then at the end, we're going to open up for general Q&A, and we also have a bunch of questions that folks have submitted ahead of time. So we'll get to those at the end as well. So now I'm going to hand it over to Chris. Did you want to start out?
Cool. Well, welcome everyone. Tim and I are excited to kick off this with a big set of announcements. But before we do that, I wanted to kind of frame up what Modular is about. So we started Modular with a big vision. So the company, if you haven't been paying attention from the beginning, is just over 3 years old. We had a set of goals that were really quite ridiculous. We wanted to reinvent software for this whole new generation of compute that's defined by AI and accelerated compute and heterogeneous compute and all these different things. And so we decided to go do this. And based on my experience, like, you want to make sure that you're doing this in the right way and you don't get distracted with things. And so we embarked on this bold, crazy vision, not knowing if it was possible, but believing that we could do it. So GPUs are the thing, right? This is a big deal for the world. AI is taking over. Gen AI, of course, it's not limited to GPUs. We started by creating Mojo and making it so that we could program these things in a much more portable way, much more accessible, and we started really leaning into this and building it. Next. So one of the ways that we explained this in the past, which, by the way, was a mistake, is we explained Mojo as a technology and Max as a product. We said that Mojo would be free and you could build on Mojo. Max would be the paid thing. What I'm here to tell you now is that this positioning was a mistake, and today we're changing it. So why is it a mistake? Well, you already know why. You've been telling us this. And so what we've been doing is we've been building, learning, listening, improving, changing what we're doing. And I think that hopefully today you'll be very excited about what this means. Next. So what we really want to do is we want both Max and Mojo to be free. We want to be available to reinvent GPU programming. We want to make a massive dent in the world. We want people to be able to use this technology both at the GPU level and in the Mojo level and in the AI level to do things that even we can't imagine. This is really what we're here to do. What we're doing is we're repositioning our products, and we're going to talk a little bit about what that means from a how we think about it perspective, also from a licensing perspective and a usage case perspective. And so we're leaning into this now. Go ahead. So first of all, we are Modular. That's the name of the company. And so it's been asked, like, why do we have so many brands? We want to reposition our products around our company name. So don't worry, we're not getting rid of Mojo. That's not a thing. But what we want to do is we want people to understand what Mojo is, what Max is, how these pieces fit together, and how it is all part of what the software that Mojo is creating and what you can use it for and why. And so we want people to say, hey, I just use modular software, right? And this can include Mojo, this can include Max, this can include lots of different things, but we want to keep it simple for people. And so if you look at what we're building this very big and evolving platform. Like, there's lots of stuff that we're building now, lots of stuff that we're building in the future, and this is a really big piece of it. And at the outer level, commercially, we're thinking about building an enterprise product. And so this enterprise product, which I won't go into all the details and the speeds and feeds and features and stuff like this, is really designed for enterprises who want to get AI into production. They want to scale it. They want it to be easy. They want to build on top of AI as a concept generally without losing the power of the underlying technology. And so we can help make that easy for enterprises to adopt and scale and go. Within that, Max, we've come to realize, is a very confusing name for a variety of reasons because we've used Max to mean lots of different things over time. What we're defining Max as now and going forward is it's our framework. It's an AI framework. You can think of it like PyTorch. You can think about it like the LLM. It is focused on inference today. Maybe someday we'll do training. We'll see. We have lots of hopes and ambitions, of course, but we want to be the best way to build AI solutions. We want to be the best way to serve and deploy things. And so we want Max to be straight out better than PyTorch for inference and better than VLLM for serving. of course, Mojo. We love Mojo. Mojo is a very important part of what we do. By the way, the modular mono repo is about to cross a big internal threshold. It's very exciting. We're about to have more Mojo code in our repo than C++ code. So this is quite important for us. And of course, what is Mojo? Mojo is the best language to build code that needs to go fast. It needs to run on GPUs, other accelerators, scale across a wide range of devices. Hopefully you already know what Mojo is. And so what we want to do is we want to make it very clear what parts of this technology can be used in both enterprise and community use cases. And your community can mean commercial, but it means, but we're dividing community being the free product and enterprise being the paid product in a different way than we did before. And so there's no Max versus Mojo split. We're now thinking about this as a community free product and a paid enterprise product. And so what are we going to do? What we're going to do is we're going to make all of Mojo, all of Max free. What does this mean? This means you can build, you can scale anything. You can make LLM servers and scale it to 500 nodes on NVIDIA. You can even use it for commercial purposes. You can compete with us. This is something that you can do with the community edition. We have the enterprise product. The enterprise product allows you to build and scale this. You get better performance in some cases. You get a self-hostable Kubernetes solution. You get commercial support. You get a bunch of additional features beyond the free product. But these two things are both really valuable, and we want folks to fall in love with both sides of this for different reasons. And so what we're doing is we're removing a lot of the restrictions on the free use of both Mojo and Max so that we can catalyze growth, we can get lots of adoption. Hopefully folks fall even more in love with what we're building. And so these two things sit together. And so you'll see this on our website soon, potentially literally right now, where we have the Modular Community Edition, which is free, and we have the Enterprise Edition, which is paid. You can contact us if you're interested in scaling AI and you want the enterprise solution. But I think that what we'll do is we'll spend a bunch of time today about talking about the community edition, because I think that's where we've gotten the most questions. Okay. So Tim, would you like to talk about this community edition and the license and the terms and?
Yeah. Hey everyone, yeah, really excited to be here. Again, particularly to this group and obviously everyone who watches the video. Again, thank you to all the support and the feedback that you've been giving us across the years. So what does this mean? What does a new community license mean? Our plan has always been to progressively open the tech, and I think we've been very consistent about it. I think Chris has talked about it. We've talked about it at multiple different presentation points. It's been talked about a lot in the community meeting. It's been talked about an enormous amount in the Discord. So I think we've been very consistent on our plans here, and we'll have more to share on this as well in the coming months. But we have spoken to a lot of folks and been talking to a lot of different people about, what could we do to make a usage of the product a lot easier and a lot more digestible for folks. So this is what we heard. One is that the license feels restrictive and is confusing. I think to Chris's earlier point, we had Max, which was originally positioned as a broad set of technologies. We had Mojo, which is a language. What can I do with these things? It doesn't seem like it's clean and easy to understand. The feedback was very directly, make it easier. So that was one. The second was, look, Mojo is a programming language. It should be free. I don't understand why there's restrictions on it. Max is paid, but Max and Mojo, the barrier between them seems blurred. So how can I use one without the other? That seems strange to me. And I think, the last was that, these concerns, there are a lot of folk who just were like, look, I'd be really interested in building my business around your technology, but it's hard for me really to understand the difference between this in a clean and simple way, right? And so I think as we've continued to evolve our products, as we've brought up GPUs, it's become clear with all this feedback that we can make some changes here to make it easier for everyone to understand. And that's really the goal. And again, even with these changes today, we would still want your feedback. It's not like feedback ends. I think we've always viewed feedback as a gift. So please keep giving it. So what does this mean? It's a pretty simple license at this point. It really comes across a couple of different tiers. So for non-production, non-commercial use, you can do anything with Max and Mojo. You can build anything. You can do anything on any device that you want to go and develop on. For production use cases and commercial use, you can do anything on CPUs and you can do anything on NVIDIA hardware. So that means you can take our infrastructure and you can go and write and develop anything that you want on those platforms using both Max and Mojo. For other types of hardware, what we've said here is you can scale up to 8 devices. And so really what we've done with the license very directly is, when you install and utilize Max and Mojo, the software can basically recognize how many devices does the software have access to. In the event that it isn't CPUs and isn't NVIDIA hardware, what we're saying here is you can go up to 8 GPUs. And if you go over that, then you really need to contact us. And the reason for this, primarily, and we talk about this, if you go to the new modular.com/pricing page, you can actually see this. There's a bunch of FAQs. The reason for this is it takes a lot of work to bring up alternate hardware, a huge amount. And on the self-hosted, enterprise product, that's a benefit that you will get from that product is that you can scale to a very large amount of not only, NVIDIA GPUs, but other types of GPUs as well. And so really what we're saying at that tier is for commercial production use, for the folks that want that alternate hardware, we think we have a really amazing offering to give. And then the last thing is if you do want to deploy on CPUs and NVIDIA hardware and use it in production and use it for commercial use, the only thing we really ask is that you tell us so that we can share your work, we can tell the world about your use cases, and that that we can utilize your logo and your brand assets so that we can tell your story and how you found success with our software. And so you can see all this now. The TLDR version is pretty simple on modular.com/pricing. So that's an easier just series of FAQs that try to answer questions that folks have given us as we've made these changes. If you want to dive into all of it, you can just go to modular.com/legal/community and you can see the updated license there with all the specifics. But hopefully that makes a lot more sense to folks just in terms of what you can do, how you can do it. Obviously, we can answer questions as you have them here today. But that's how we're positioning it. So next slide.
So before we go on, can I ask you some frequently asked questions, Tim?
Yeah, absolutely, Ken.
So if I want to run Max for free on a 500 node NVIDIA cluster, can I do that?
Yeah, you absolutely can do it. If you want to do that in production, the only thing we would ask you is please tell us you're doing it so that we can advertise that you're doing that. That's obviously an amazing success story for us too. So not only is it great for you, you've been able to utilize what is an incredible piece of technology and software that we've developed now over more than 3 years. But the benefit that we also get, and that by the way you would get, is that we get to tell that story as well. And so that's a really important part.
So frequently asked question, can I run Mojo on an Apple GPU for free?
Yeah, so again, the answer to that is yes. We don't officially support Mac GPUs today. We get a lot of requests for this, by the way. And again, we'll have some announcements in the next few months that hopefully make it easier for folks to help us develop on Mac GPUs. But the answer is yes. Even though we don't currently, officially support that, but obviously there's a lot of interest in how we could enable that for the world as well.
Yep. So cool.
So you had questions, please ask. Yeah. Please ask. We can answer them. But in the interest of just keeping things going, the reality is, if you have any other questions, you can just contact us, right? Like it's pretty simple. The forum is very available. We all see it. We are all notified daily. Carolyn and Chris Hodge do an amazing job with Bill and the rest of the team in monitoring it. And if there's questions, we try to get back as fast as we possibly can. So, and then separately, we have licensing at Modular as well, which is an open inbox. You can also ping either Chris or I. Certainly my email is just tim@modular.com. And if you have questions on this stuff, we're very happy to help guide you so that you can build with our stuff and really help change the world, which is why we started this company in the first place. Yeah. Next slide. So what's next? This is actually out of date because our website is now up to date. So that's how quickly we're moving here at this point. So our license and pricing pages have already been updated. So you can go there now and see them live. And of course, like I said in the beginning, we make these changes because we listen and we listen to what you've all had to say. We've listened to a lot of other folks. We want to continue to do what's right by the community and obviously by all our enterprise and design customers. I think folks are really excited about this. It does enable them to go and build some really interesting things. We want to see what the world builds with our infrastructure. So, but the point of the last dot here is, but that doesn't mean that that the end is here. Please keep giving us feedback. And obviously we will keep listening and doing what's right to make it easier to deploy and utilize our software. And lastly, we really feel like we've struck a fair balance too, right? We are a company. We ultimately want to be here for the long term. We want to be able to provide all this infrastructure and continue to develop for the long term. And so, we are also excited to help scale, enterprise customers as well.
There's a couple of questions in the chat. I'll answer them lightning round real quick. So someone's asking, what about packaging and can I get Mojo without Max? The answer is no, not right now. So they're pulled together. What we're doing is we're shrinking the Max package and making Max as easy to use as Mojo, and making the same license free. Go nuts with it. We are evolving packaging, and we have something really cool to talk about coming in a few weeks. And so that'll be really a big deal, I think, which will make it even easier to use Max and Mojo together. But for at least the foreseeable future, we want to keep these things together. And you can think of Max as being basically just a library, or GPUs as being like a library that's part of Mojo or something like that is one way to think about it. Owen's asking, how does 8 devices or fewer work? The answer is that whatever reports to the system as a GPU. And so many GPUs have thousands of cores in them or something like, well, cool, that's an implementation detail. Does it show up to the operating system as a GPU? If so, then it's one device. And so you can go look at that. In the Max APIs, you can say enumerate your GPUs and it will give you a list. So it's very simple. And Gabriel, awesome, great to see you. Max is the way we're defining Max is it's a AI framework. So think of it comparable to PyTorch, just much smaller with way less stuff and focus on inference. And so put it in that category. And so that's the way to think about Max. Obviously, Max is quite early on, and so it will continue to grow rapidly over time. And so like PyTorch is not, I wouldn't say that PyTorch is a library. I'd say PyTorch is a massive ecosystem of stuff. And one of the things that PyTorch has is it has a Python package that you pip install, but it's got a lot of stuff involved in it. And so I don't even know how to define PyTorch myself. Seth is asking, does it change the timeline to open source the Mojo compiler? The answer is no. And so, we'll have some open source announcements also that I'm very excited about. We're not quite ready to share those, but stay tuned for perhaps just a few more weeks.
Thank you. Any other questions on the license updates before we move on? Going once, going twice. Okay. Then I'm actually going to hand it off to Brian.
All right, thank you. Hello, everyone. Brian, I'm back once again. Talk to you about a library I've been working on called Kelvin, which is for dimensional analysis. I don't have any slides today, so I'm just going to be kind of yapping at you over code today. Some background how I got here. I had been discussing kind of in the community about kind of sort of porting something like this from C++, which is basically a time duration or interval representation library that kind of lets you treat different intervals as distinct types. And then actually Owen from community was like, hey, what if we took this like a little bit further and took inspiration from this Rust crate that just it kind of extends this idea into more of a general dimensional analysis use case. And I thought that was really cool. I started taking a look at it to see like, okay, like how do you even do that? And kind of what I understood is it's kind of based on this encoding the dimensions of the type the value, I guess, into the type system. And in this case, just uses some like zero size struct that conforms to a trait. And then kind of what you get in the end, like for instance, this is how they encode acceleration. So you have a negative time dimension and a positive length dimension. And it's kind of the way they do it, I think it's kind of a little bit messy to read and whatnot. And then kind of dawned on me that after looking at Chris's changes to the literal stuff, and I was like, we can actually like do this pretty nicely, I think, in Mojo just by using that. So here, my version of this struct is just a bunch of int literals as parameters.
Hey Brian, as usual, we being the Mojo team broadly are not communicating super well about fairly profound things like dependent types and int literals. Do you want to take a little bit of time and explain to people that are not deep in that, like why it's cool and what it is and stuff like that?
Uh, I'm not sure if I could do a very good job, to be honest with you. Maybe uh, as far as the
Okay,
dependent
no
type
pressure.
stuff.
Sorry, keep going.
Yeah, that's sorry. I wish, but I'm not sure I would do a very good job. But essentially, what it how I've used this is essentially um, just encoding information to the type system and making sure that all these things are always like compile time computable, I guess. Um, so for instance, like when you like, uh, say you divide a length by a time, right? You get velocity. Um, and here I have this quantity struct where when you divide one quantity by another, um, yeah, you get that sort of like derivative of it. And then here, which is kind of the special sauce here, is I'm dividing the dimensions in the out type.
Okay,
Um,
so can I try to explain it at high level? So what's going on here? So
absolutely, absolutely.
the integer, float, and string literals are now all aligned. The string literal landed yesterday, actually. Um, and what they do is literals. So this is where you say one or 4.0 or quote foo. What it means is that when you do that, you're encoding the value of the literal into the type. So what that means is that now you can encode effectively type transfer functions at compile time into the type system, which then allows you to have very safe and very powerful ways to express things like you're doing, which you should talk about your domain also, because like explaining why you're doing this is really cool. I think you're the expert on that. But this is really pretty significant. And other languages have had like special language features and weird hacks to allow different kinds of units and things like this. And so it's very nice, and I'm very impressed with your work here because you can take a completely generic language feature and now use it to do something that defines away features that other languages had to like create just to support this use case. And so encoding stuff in the compile time metaprogramming type system, I think is really powerful. And I love that you're exploring this because this is the kind of fundamental technology capability that unlocks really, really fancy use cases like you're exploring here.
Yeah, thank you very much for that explanation. That's better than I could have done. So, and essentially how dividing the dimensions is defined um, is you just take the element-wise dimensions of each and then just subtract them, right? So if you have, and then I just kind of sort of explain how that will work. You see like a meter is just defined as a quantity with one length dimension and 0 dimensions everywhere else. And then, so same way, a second is just one time dimension and nothing ever else. So then when you sort of take the derivative here, you get -1 time dimension and then 1 length dimension. And this being just, just a number in the compiler information, you can obviously just represent arbitrary dimensions this way. Kind of what I was originally playing around with it, I was trying to just do like each, I guess, like configuration was its own struct, and then I was like, well, this doesn't really work generally, so I need to like dig a little deeper here. Um, so then this is kind of what I've come up with so far. And then similarly, if you multiply two dimensions, then you just add them together. So for instance, like area is just two length dimensions, right? And this is just kind of a little piece of syntax I came up with where if you it's just taking the power of the dimension, which is just gonna multiply each dimension by that value. So that's I guess I'll show how it's kind of more useful in an example a bit later on. But I think that about sort of explains the approach here. It's really short, actually. It's only like 190 lines of code to do all of this. Um, and basically at this point, most of the work I'm doing is just making things kind of like adding more support um, for like for instance here, like I have just helper functions to convert from a kilometer to meters and stuff like that. I think I'm still experimenting with the concept of sort of encoding the scale as well into the dimensions. That's a little bit more complicated, and I've kind of been running into issues accomplishing that, but I think I could probably get there eventually, and I think that would be pretty cool. Sometimes, like I imagine certain people representing everything as like the base units isn't might not be super practical, maybe from like a precision standpoint if you're doing planetary physics or something crazy like that. So then I'll just do a little demo, kind of like how this all composes in the end.
Actually, Brian, if you're interested in planetary physics and things like this, like the floating point literal type, the float literal in Mojo is infinite precision. So you can represent as many digits of precision on your floating point numbers as you want. The only catch is that at some point, so that's only valid at compile time.
Mm.
And so then you need to do a bunch of math at compile time with literals, but then you convert it into some runtime format. And so typically convert it into like a float 64 or something. And so that conversion is where you lose or you bind whatever precision you have.
Mm.
And so
Yeah, for sure. I think maybe at this point, I'm just the quantity is just generic over the D
that's right.
type. Because we don't really have a way of representing, I guess, like being generic over like all different sort of like numerical types. But I think in the future that would definitely be something that would be cool to try to implement. Yeah, so like I said, it's generic over D type. So by default, it's a float. But if you want, you can use integers. And here, kind of as I mentioned, divide a meter by seconds, then you get meters per second, and that's all type safe. And as I mentioned, this is this is just defined as an alias for a particular quantity. So and then kind of yeah. So then here we have area, and then just kind of to show how easy it is to sort of compose these into other more complex types. I just take an alias to kilograms, meters, and seconds, and then you just basically just write out the expression as you would expect it. So we have kilograms times meters times seconds to the power of -2. Um, and then have some code for just actually formatting out I guess the unit representation as well. So if I run this, like you see, then you get 100 meters, kilograms, seconds to the -2. So I think I think I'm just really scratching the surface here on what we can do in this with this kind of stuff and just offloading as much as we possibly can into the parameter domain. I actually have one more example of something a little bit more cursed, maybe.
Actually, before you go on, Owen, do you want to? It sounds like you're a fan of Brian's work here. Do you want to chime in about how this compares to some of the other systems out there?
Yeah.
Sure.
So the reason that I proposed doing it this way originally is that the way C++ handles time is very disconnected from how you would handle every other unit, which is a gigantic pain if you're doing scientific computation. The Rust library, does a little bit better, but it actually predates the ability to have numbers in generics, which means there's a lot of weird things. They used to use a library called typenum, which used church encoded numbers, for those of you that know what that is. And it was absolutely horrible to use from a compile time standpoint. So when the discussion about time came up, what I wanted to bring into it is let's try to make something that actually helps HPC people who we want using Mojo to get their units right and kind of enhance that it compiles, it works. Because usually, if you're doing scientific calculations, if you have the right units at the end, it's probably correct. And I just want to say I'm very happy with where Brian took that idea.
Oh, I think I have a question. I think I have a question. Sora?
Oh, yes, I do have a question. Do you think, uh, well, essentially you are modeling units as a free Z module, right?
As a what, sorry?
A free Z module. So think of it as a vector space, but the coefficients are integers.
Yeah.
But there are times where you probably want the coefficients to be in fractals, sorry. So you can have square root of second or something like that. So do you think this is sufficient?
That's a good question. That's definitely something I haven't thought of much. I think the
think
irony
you could
is
use ratio there, but
yeah.
sorry. But
Yeah,
yeah,
there's
the
definitely
ratio
a,
is also very cool. Yeah.
yeah, there's definitely a way we could do that.
I
think
mean, but that is ratio on the type level, right? So you essentially need to model rationals.
yeah,
I think you should show the ratio. It's very cool. Yeah. I'm also very excited about it.
yeah,
Yeah.
yeah, that's true. Yeah, maybe I'll just quickly. Yeah, so I've kind of put together this ratio struct for basically doing exactly that. Um, and it's not used here too much. It's mostly just for like these helper functions, like I said, where you're basically just casting like a 1 kilometer into the equivalent of meters and stuff. Um, so it's just numerator and a denominator, and just has like whatever functions defined on it that are required, like multiplying like a ratio by a scalar just transforms that scalar based on the given ratio. And actually also another cool thing here, we can do sort of like ratio simplification also at compile time, because we can compute the greatest common denominator as an alias and then use the same sort of output type trick here, which I think is really cool. So I think that's definitely something that we could, I think we could add more complexity, I guess, to the representation of each dimension and to like accomplish something like that for sure.
Cool. That's nice.
Oh yeah. And then I guess kind of one more example of kind of the stuff I'm messing around with. This is just, I wrote like a more, an actual more close implementation to the chrono duration thing, as I've kind of been using it more of like as a playground for these crazy ideas at this point, because it's easier to make changes to this than it is to make changes to the quantity struct, I guess. And here, one thing that was kind of bothering me was in the C++ library, if it knows how to basically like auto lower to the highest resolution time frame. So if you add like 10 minutes or like 5 seconds to 10 minutes, then you get a seconds type out of it. And I was having trouble figuring out how to do that in Mojo. And then I finally got it the other day with this kind of horrific expression in here, which basically how that's working is the ratio is encoded to the time struct. And I wrote this little piece here, which is basically doing like a branchless ternary and picking the smallest ratio, and then applying the appropriate suffix to it, which will be like in this case, it'll be like S for seconds. So that was something which I originally, in fact, when I was writing a proposal about it, I explicitly said this probably isn't possible. I eventually did figure out a way to do it. It's just completely unreadable, but it does work. So yeah, I think that's about all I have to share. Is there any other questions?
Awesome. Thank you, Brian.
Thanks, guys.
All right, I'm gonna share my screen. Can everybody see that?
Yep.
Cool. So now we're going to do some more general Q&A questions that were submitted ahead of time, but if you have any other questions, feel free to drop them in the chat too, and we'll get to those. So starting out with a question from Gabriel. When working on GPUs with a small struct, for example, span, that has two attributes of size 64 bits each, will each attribute go into one 64-bit register automatically, or will it spill to global memory if no register is big enough to hold 128 bits? I'd like to use span with zero cost abstraction. Maybe a question for Chris. Oh, you're muted.
I can take it if nobody else wants to, but I'm happy for somebody else to take that. So the answer is yes, this span is efficient on GPU. So you can definitely use register passable types and other things like this, as well as memory types on GPU. So this is super awesome. This is what Mojo is designed for. One thing to watch out for is you can't malloc on a GPU. So don't use like a list or a string, but you can totally do this. We also have abstractions, which I think other folks are better positioned to talk about in terms of being able to have tensors on the stack and allocating global memory and things like this. And so span's a good way to talk to those.
Thank you. Is there a Mojo roadmap coming for 2025? Any further thoughts on what a 1.0 would look like?
Yes, there is definite progress on this. We don't have anything we can share right now. There's lots of cool features happening, and I think the team's getting more organized, and so we'll definitely share when we can.
Thank you. In the CUDA blog post series, good incentives is given as a requirement for a successful AI framework that would work on any hardware. Is there any incentive for Modular to make Mac/Mojo work well for edge devices or even consumer GPUs, since Modular only makes money with a cloud platform?
Yeah, so I'll answer this in a couple of different ways. So the first way to answer this question is, we're a small team, we need to be focused. We're focusing on kind of data center and those kind of bigger GPU applications instead of like deep embedded or cell phones or things like this. But that's really today's situation. We expect this to change, right? And so we're just bringing in our GPU support now. As Tim shared in the licensing discussion, the reason we're opening up Macs, and this will take many forms this year, by the way, but the reason we're opening up Macs now is because we're getting to this inflection point where we've proven we can have GPUs that meet and beat NVIDIA on their own hardware. That's a thing that many people thought was impossible to do, but we've done it. And so now what this enables us to do is go into a new phase. So we will be expanding in a variety of ways across this year and into the future. And so when you look at our products, well, our products are one aspect of how we're looking at this. And so maybe we'll expand and have an edge product or something over time. Maybe that's possible. But we also don't think we have to do all the work. And so today, we're changing the binary license for being able to use Mojo. Coming soon, other things will change. And so our goal is to really catalyze this next generation of compute. And we know that we can't do everything ourselves.
Thank you. Does the modular team want to make Mojo/Max only good for production use cases, or does it also want to make them good for research? Do you want to support training models at some point?
Well, so separate these two things. So first thing is research. Well, research means lots of different things. I look at research as meaning innovation broadly. There's a ton of research on inference, and so it's not, research isn't just about training. I think that Max and Mojo, particularly in a month or so, are uniquely positioned to catalyze research. I think that this ability to have a very open stack that's designed from first principles, that's it's not perfect, it's still evolving, it's still converging, and we're still making things better, but it's designed for this work, I think is a unique opportunity for us as an industry to help invent new technologies, new research, get research in production faster, and all that kind of stuff. And so research, I think, and innovation is one of the major points that is really interesting about what we're doing. I'm really excited about that. Separate question is training. Okay, so training, I'm very passionate about that. I love large scale. Just in the 25.2 release, we added multi-GPU support, and so that's a really big step forward. We don't have distribution support yet, and so for real training, you need multiple nodes, and so that will come over time. That said, you're not bound on modular. And so NVIDIA, for example, already supports training. I'm very, very excited to see this. I think that with me as my modular business leader hat on, not as a technologist, like I want our team to stay focused on the inference problem because it's not done yet. We need to build it out. We need to stay focused. But absolutely, I want Max to be better than, for example, JAX training.
Thank you. Is there help given by hardware vendors to the modular team to add support for their device on Max/Mojo? Do you sometimes do reverse engineering? How welcoming are the hardware vendors with your approach?
So it's a great question. This is one where I'd rather not answer. So like our relationships with different partners are something that, we'll work with the different partners. We're very open to work with the right kinds of partners, and that's very important to us. I can't speak on their behalf.
What's next for the trait/type system? Trait intersection types, associated types, including generic associated types, where clauses, negative bounds, given that implicit conformance is being phased out, or something else?
I would love for somebody else to talk about this because like almost everything on this list is a yes. Evan, is Billy here? I don't know. Can't see the list. Evan or Dennis
Yeah.
or
I can talk a little bit about this. So associated types, there's going to be, I'm going to be working on those a little bit more soon. I'm going to upgrade them, fix some bugs in there. I really want to make them work for iterators really well. We kind of have them working for iterators, almost kind of, but there's some sharp edges that I want to fix there. Trait intersection types, I believe is coming soon. I think Billy's working on those. I can't really speak much to where clauses or negative bounds or implicit conformance. I've heard those words being tossed around, but I don't know any status on those.
where clauses are requires clauses.
Oh, okay. Then, Chris, you're the best person to talk about that, I think.
Well, so we have a proposal for this. I think if Dennis will let me, then we could share it publicly. It hasn't been, the engineering work hasn't been started, but I think it's within reach. So we just have to decide to embark on that. I think that'll be a big thing. I don't know what negative bounds are. And so I'd ask Ben to perform and give an example of what you want to express. But TLDR, yes, generic systems getting major new features, and there's lots of cool stuff going on. So, and a lot of it's coming together like next week's-ish. So that's also exciting.
Sora, does that answer your question?
Yes, that is great news. Thank you.
We also have an in-person community meetup coming up next Thursday on April 24th at the Modular office in Los Altos, California. So if you are in the Bay Area, definitely stop by in person. If you are not in the Bay Area, there is also a virtual attendance option. So either way, if you're interested in checking out the talks on GPU programmability with Mojo and Max, RSVP. If you're interested in attending virtually, you can just select the virtual attendance option on the event page. Definitely reach out if you'd like to present at our next community meeting next month, and we'll see you then. Thank you.
Thanks, Bob.